Your assignment today is 382A, 1 through 20 all, and 59 to 65 odd. So take a look at 382. We're dealing again with logarithms. And it says on 1 through 20, apply the properties of logarithms to simplify each expression. Do not use a calculator. This wants you to use the change of base formula, but let me review some of the properties of logs, and then we'll work on that portion of the assignment. If I had 4 to the third equals 64, how do I convert that into logarithms? Log base 4 of 64 is 3. Now, let's say I didn't know what it equals. How do you evaluate log base 4 of 64? So we don't have fourth gear in our calculator. We have a log button and we have an ln button. How do you change this into either log base 10 or log base e? Either log 64 over log 4 or ln 64 over the ln of 4. So ln 64 divided by the ln of 4 is 3. Okay? Let's review another rule, the power rule. If I have log base 2 of x to the 4th, what can I do to change that? What can I do with the 4? I can drop that 4 into a multiplication for log base 2 of x. And you can likewise put this up here if you want. That is called the power rule. The power rule is the reason we invented logarithms. And we'll get into that in a later assignment. Okay. There's another rule called the product rule. And the product rule says this. Log base A of B times C is exactly the same thing as log base A of B plus log base A of C. That is called the product rule. Likewise, we have a quotient rule. Log base A of B divided by C is equivalent to log base A of B minus log base A of C. Okay. Good question. So let's say I have log base 5 of x times x minus 3 over y times z. Can we expand that into something larger? Well, every product, every factor in the numerator gets a positive logarithm. Every factor in the denominator gets a negative logarithm. So this will get its own positive. This will get its own positive. And then both of these will get negatives. Hang on, I'm answering. It'll take me a second to get there. Sometimes. So when we have quadratics, don't we frequently factor quadratics and make them longer? If I had an x to the 5th, doesn't it make sense sometimes to do that? Oh, one more. Yes. Does sometimes it make sense to take all the factors and then put them back together? And it's basically the same reason. So sometimes expanding it is going to make it easier, and sometimes condensing it is going to make it easier. It just depends on what you're doing. So we're going to learn that skill, and then we'll get to the the use of that in a minute. Well, maybe not even today, but that is a valid question. Why would we want to pull it apart? Well, you want to pull it apart so you know how to put it back together. And then if you know both of those, then we'll work problems where sometimes you need to pull it apart and sometimes you need to put it back together. So here we will have 4 logarithms. We have 2 factors in the top and 2 factors in the bottom. Log base 5 of x plus log base 5 of x minus 3. And then the 2 in the denominator get a subtraction. Minus log base 5 of y minus log base 5 of z. Does everybody understand that? Yes? Why are these rules in place? Well, they're just exponents. Every logarithm is just an exponent. So this is asking 5 to what power is x? This is asking 5 to what power is x minus 3, and then so on. And if you multiply the stuff inside the logarithms, you add separate logarithms. Yes? So they're in the denominator. So, right, but they're both in the denominator. Yes. So here's what's really going on. If I had x to the 5th times x to the 4th over x to the 6th, when I have 2 bases multiplied to each other, what do I do to the exponents? You add them. So that's like saying x to the 9th. But on the bottom, if I had x to the 6th, what do you do with the 9 and the 6 in this case? You subtract the 6. So, Bretland, if I put an x squared down here, I could add those together and get x to the 8th, but overall they get subtracted. So you have 2 options, and usually I don't teach this, but you pointed it out. You could say minus log base 5 of y plus log base 5 of 2, or sorry, z. That's a z. But you'd have to put it in parentheses, right? And we don't do that. These are multiplied by each other, but they're both in the denominator, so there's a negative out front, and then I would distribute the negative. So in general, we just say, if it's on top, we add. If it's on bottom, we subtract, because it saves us a step. It makes it a little less confusing. So I want to show you how the power rule and the product rule and the quotient rule are really all the same thing. So let's say I had log base a of x to the 3rd, right? I can take this and drop it out front and get 3 log base a of x. Or I could say this is log base a of x, 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 right? And how do you split this? How do you split log base a of x, x, x using the product rule? So log base a of x plus log base a of x plus log base a of x. Are those 2 things equal? Is this 3 copies of log base a of x the same thing as log base a of x, log base a of x, and log base a of x? Yes. So the product and the quotient and the power rule are really all the same thing. And you need to know how they work forward, and you need to know how they work backwards. So the power rule allows us either to drop an exponent or take a multiplication and turn it into an exponent. The power rule allows us to take a single logarithm with the product inside and split it, and the quotient rule does the same thing for division. Okay? So take a look at number 1. Doesn't want you to use a calculator. can we simplify these? So what is number 1 asking? Well, we don't. So can we find the answer? Do we know what it is without plugging anything into our calculator? It says 9 to what power is 1? 0. So number 1, the answer is 0. Which, if you did, yeah, it just wants you to simplify, evaluate it without plugging it into your calculator. So you need to understand how logarithms work. So number 2, log base 69 of what is 1? 0 again. Any number to the 0 is 1, except, what about 0 to the 0? That's a mess. But will you ever have log base 0? No. Log base 0 doesn't make any sense. It would be, how many zeros do I need to multiply together to get, say, 6? It'll never happen. So log base 0 is kind of boring. All right, number 3. What's the answer to number 3? It's just 1. 1 half to what power is 1 half? 1. Number 4? Number 4 is 1. Number 5? 8. Now there are two ways to do that. You can either say 10 to the x equals 10 to the 8th, and it's obvious that x is 8. Or I can take this 8 and I can drop it out front, and I get 8 log base 10 of 10. Well, what is log base 10 of 10? 1, and 8 times 1 is 8. Okay, number 6. ln of e to the third. Why 3? ln is base e. So basically, e to what power is e to the third? It'd be 3. Or you can drop the 3 out front. 3 times the ln of e, and the ln of e is 1. So 3 times 1. Okay? Does anybody not get what we're doing? This is pretty... Okay, so next one. So 10 to what power is, and that's 1,000th, right? So 1 over 1,000. So negative, we'll flip it upside down, and 10 to what power is 1,000? 3. Right? We need 3 tens to create 1,000. 10 times 10 is 100 times 10 is 1,000. So the answer is negative 3. Did I skip 6? Yeah, 6 was 3. Okay, 9. What is the exponent on 8? Not 2, 1 half. So it's saying log base 2 of 8 to the 1 half. What can I do with the 1 half? Put out front. Okay. And then 2 to what power is 8? 3. So this is the number 3. So 1 half times 3 is 3 halves. Okay. Now there's another way to look at it. You could also say that I have log base 2 of 2 to the third to the 1 half. Because 8 is 2 to the third, right? And what is 2 to the third to the 1 half? 2 raised to the 3 halves. So 2 to the x is 2 to the 3 halves, so the answer is 3 halves. Both of those ways work. I probably would recommend pulling the 1 half down and then evaluating the logarithm, but that also works. It's the exact same thing. Usually, well, frequently, there are 2 ways to look at logarithms and solve them. And there are only like 3 or 4 things that you can do. So if you look at something and you don't understand it, start applying the rules and start converting. And if it doesn't work, then go in a different direction. And there are usually multiple ways to solve those. 14. So 10 is just 5 to what power is 5 to the 1/3? It's just 1/3. Right? The third root is the 1/3 power. Does that make sense, Casey? What do you not get? So the third root of 5 is 5 to the 1/3. Well, no. So now 5 to what power is this? Which is just 1/3. 14, you want me to look at 14? Okay. Okay. All right, number 11. So let's set this equal to x. And now let's convert to logarithms. Log base 8 of x is log base 8 of 5. So x is 5. Okay, we just learned something. We know that log base 8 of 8 is 1. Okay? Likewise, 8 to the log base 8 of whatever's in here, this basically just cancels. It turns into a 1. Now, it's more complicated than that, but it will happen every time. If the base of your exponent and the base of your logarithm match, you can just delete those. Just like log base 8 of 8 is 1. So if you look at number 12, the answer is 5, because essentially those cancel. No, that's not totally true, but when we rearrange it, we get log base 2 of the unknown is log base 2 of 5, so this and this have to be the same number. Okay, 13, the answer is x plus 5, because e raised to the ln cancels. What about this one? It's just this. Yeah, it's not asking for the roots. It just wants to know, how does this simplify? And it simplifies because log and the base 10 cancel. Okay, number 15. So and they didn't write this very well. 5 raised to the 3 log base 5 of 2. What should I do here? Put the 3 up on the 2. So I'll use the power rule to lift this up and put a 3 there. Right. So now 5 and log base 5 cancel, and I'm left with 2 to the 3rd, which is 8. Or, if you would prefer, we have 3 copies of this. So 5 to the log base 5 of 2. This turns into 3. Or sorry, that turns into 2. So this equals 2. And I have 3 copies of those. And that's where the 8 comes from. So again, there are usually 2 ways to look at these logarithms. Okay, number 16. So we're going to lift the 2 up, and we get 5 squared, and the 7th cancels, so the answer is 25. number 16 or 17. 1 over 9. So the 2 comes up, and I get 3 to the negative 2, which is 1 over 9, and then the 7's cancel. The answer is 1/9. Number 18. So it's just going to be 1 over 100. 18. So the negative 2 comes up, and I get 10 to the negative 2, which is 1 over 100, and then the ln and the e go away. Okay, so this is 7 copies of whatever the rest simplifies to. So if I got rid of the 7, what would the answer be? X to the negative 3, also known as 1 over x to the third. So this becomes 1 over x to the third, and I have 7 copies of that. So I just multiply straight across, 7 over x to the third. Okay, from here, well, on the next set, we're going to be let's go back to here. Oh, really? Hang on a second. Let me double check something. Oh. Hey. Give me just a second and I'll be ready to go. Okay, this assignment actually has you skipping down to the story problems. Don't do those right now. I need to fix this. But wait, hold on. We're going to do the next one. So 382b, which is so I'm actually just going to change the assignment online, but you guys, anyway. So there is the second assignment. Keep them separate, and then you'll get credit for both. Yeah, don't do the story problems. We'll get there, but I don't want to do them right now. Yes. Hang on a second. Let me do 21 to 47, show you how to do these. So take a look at 21. So number 21, we need to expand this. Well, I have a product of 2 factors, and each factor has an exponent. So I'll split this into 2 positive logarithms, and I'll drop the power on both of them. So this will be 3 log base b of x plus 5 log base b of y. Does everybody understand that? So I drop the 3 and I drop the 5, and both of those are in the numerator, so when I split them, they're both positive. Okay, take a look at number 35. Yeah. What's that? Okay, so we're expanding, and we have 2 factors. They're both on top, so they're both positive. Right, they're over 1. So we have a log base b of x, and we have a log base b of y, but there was a 3 here that dropped down, and there was a 5 here that dropped down. Okay, take a look at 35. Um, it's basically what was it, 21 to 47 odd. Well, and I'm going to throw that second set out. So just do 41 or 21 to 47 odd. Yes. Okay. All of this has a 1/2 power. Everybody agree? So every natural log that we write will have a 1/2 power in front of it. Okay, but this will factor into x minus 5 plus 5 and x minus 3. What does the bottom factor into? X minus 2 and x minus 1. So I will have 4 logarithms. 2 factors on top will be positive, and 2 factors on bottom will be negative. Everything has a 1/2 power, so all of the natural logs will have a 1/2 in front. Okay? Or if you're lazy, I guess you could just do 1/2 and then a big set of parentheses. But my guess is that's not how it's in the back. Who knows? Cynthia doesn't follow the rules. So we have ln of x plus 5, 1/2 ln of x minus 3 minus 1/2 natural log of x minus 2 minus 1/2 the ln of x minus 1. That make sense? Well, you get it? No problems there? Factors in the numerator turn into positive logarithms. Factors in the denominator turn into negative logarithms. Everything had a 1/2 power, so I dropped the 1/2 on all of them. Yep. No, the logarithm is positive. This is positive, and this is positive. The factor itself is x minus 3, which may be positive. Well, it has to be positive, because if it's negative, then it's not part of the domain. So you're not allowed to plug in like 2. 2 is not part of the domain, because 2 minus 3 would be negative. So 27 will have 3 logarithms. The first one will be positive, and the second 2 will be negative. And then on the next set, all you're doing is going backwards. So look at 45. If you're going to condense them into a single logarithm, the bases have to be the same. So on 45, are the bases all the same? Yes. So I'm going to lift that up and turn it into a squared. These will be multiplied by each other. So I have the ln of x plus 1, x minus 1, and then x squared plus 3 squared. Does that make sense? We didn't pull it out. We condensed it using the product and quotient rules. No. Because if I took this and split it, I would end up with 3 logarithms. So we're just going backwards from the set before. Okay. So my guess is Cynthia's going to put that together. What is x plus 1 times x minus 1? X squared minus 1. Whenever you multiply conjugates, you get a difference of perfect squares. No. So log has a 10 down here that we don't write, and ln has an e that we don't write. So if the base is not listed, it's a 10. The natural log has base e, which is 2.7. Okay, what question did you have? Number 20. Oh, I skipped 20. I'm sorry, guys. On the other assignment. So we're going to lift this up. We have negative 19 times this and this cancel, and we end up with x squared to the negative 2, which is x to the, nope. What do you do when you raise an exponent to an exponent? Multiply x to the negative 4, which drops it to the bottom, so negative 19 over x to the 4th. So really, your assignment is 1 through 20 all, and then 21 to 47 odd. And for you guys it will be, but all future classes it will be as one single assignment. 31. So they just used brackets as very large parentheses. So for 31, you'll have 2 logs on top, or 2 positive logs, and then 1 negative log, right? 31, you'll pull out a 3 and do the ln of x, and you'll pull out a 2, ln of x minus 2, and then you'll have negative 1/2 ln of x squared plus 5. Mm-hmm. Okay, so number 31. So positive, 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 and then this next one will be negative. So drop the 3 ln of x plus 2 ln of x minus 2, and then minus 1/2, that's the square root, ln of x squared plus 5. All right? Okay. Good luck.